everyone. So we're gonna be talking about organic chemistry. Okay? And so here, one thing that I would like to start just to talk about before we can dive deep. Let us remind ourselves of what we call the molecular formula and the structural formula. Right, so for instance, let's take a compound, let's take propane. Yeah. Let's take propane. So with propane, you know that if we draw a structural formula, it has how many carbons? Because since we're talking of organic chemistry, it's basically we're going to be dealing with compounds that contain your carbon, your oxygen, hydrogen, as well as your halogens. Those are the most commonly used atoms that we'll be dealing with here. So propane, we do know that, or if you don't, let's start here and say that, okay, when we are counting in organic chemistry, 1 is meth, 2 is eth, 3 is prop, 4, that will be your but, 5, that's gonna be pent, 6 it's hex, 7 that's oct, 8 that's hept, 9 it's nano, nano, yes, we can write that. Then 10 it's your deca, but these are the most commonly used. Very, very rarely that you would see an organic compound with 10 carbon atoms. So now that we know that, okay, 3 it's prop and it has how many carbons, this basically represents the number of carbons in that organic compound. So propane now has 3 compounds, carbon atoms, sorry. So that would be 1 carbon, 2 and 3. Then another thing or another property that you need to know of carbon is that if we are talking of carbon, you need to know that carbon bonds how many times? 4 times, right? Because it has a valency of 4. That's from your periodic table, but we won't go there. So carbon bonds 4 times. Ne? It can form single, double, as well as triple bonds, but we will see and we'll talk about that when we get there. So now we need to fill this. It's because we know that carbon bonds how many? 4 times. So we will fill these remaining bonds with hydrogens. So we're going to put hydrogen, 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 like that. And that's the structural formula of propane, right? And if now you want to write the molecular formula of that, so this is the structural formula. And if we want to write the molecular formula, we're gonna say it's basically C, how many carbons that are there? There's 3 carbons. And H, how many hydrogens that are there? It's 1, 2, 3, 4, 5, 6, 7, 8. And this becomes your molecular formula. So that's how we write the structural as well as the molecular formula of propane. Ne? I don't want to dive deeper into, for instance, taking alcohols, esters, as well as aldehydes and everything, but we'll get there when when we do that. But I just wanted to just a recap, because we did this at grade 11, if I'm not mistaken, or grade 10. So I just wanted to do a recap on that. Then now let us talk about homologous series, right? Let us talk about homologous series. But before we talk about homologous series, I just want to touch on something. So I talked about propane there, né? And propane is part of okay, because I think I'm gonna confuse you if I start with that, né? But it's fine. It's fine. It's all right. So let's talk about the homologous series, or basically just the most commonly used definitions that you will come across, but in a stepwise approach. So the first one, so definitions, the first definition that they would ask you is homologous series. Homologous series. So basically, homologous series, it is a series of compounds that have the same general formula as well as the same functional group. So a series of compounds with same general formula as well as same functional group. And I talked about functional group. What is functional group? So functional group, né? It's whereby now it's atoms, or a group of atoms that define the chemical as well as the physical properties of an organic compound. So it is an atom or a group of atoms that define the physical as well as the chemical properties of that particular atom. Right. Now, let's see all of these homologous series as well as functional groups in a table. Maybe it's going to be easy to understand in that way. So let's talk about our homologous series. So the first one, we call them hydrocarbons. Hydrocarbons. And hydrocarbons are basically, let's write this in capital letter. So hydrocarbons, it's basically organic compounds that contain only hydrogen and carbon atom, right? And under the hydrocarbons, we have three subcategories, whereby the first one, it's your alkanes. The second one, it's your alkene. And the third one, it's your alkyne. And what is the difference there? So basically the difference there is in the number of bonds between carbon atoms. The difference between these three, it's in the number of bonds between carbon atoms. For instance, if we take a compound that we're going to be using here and say, for instance, I'm going to take a compound with, again, maybe 2 carbon atoms. When drawing a structure of that, first of all, that particular compound will have 2, because of this, it will have 2 carbons and will have single. So here there's single carbon bond, or single carbon bond. Yeah, you can write it that way. Or there's a single bond between two carbon atoms. Then here it's double bond, and here you have your triple